Okay, we are going to multiply this complex number. We're actually squaring it. So we are multiplying it by itself. A couple things to keep in mind. We need to write our answer in standard form. And one thing that will present itself here is this idea of I. I, we know, is the square root of -1. If, however, we get I squared, that's going to basically be this, right? It's the square root of -1 squared. The square and the square root will cancel, so I squared is really equal to -1. That's a big deal. Anytime we see I squared in this context, we're going to want to replace it with -1. Okay, a couple things to point out here. The most common mistake I see people making on a problem like this is people want to distribute the square. They are going to immediately go 9, because 3 times 3 is 9, and then they'll do -36I squared. That is partly right, but that is not completely right. We do not actually want to get that full answer. So let me go ahead and kind of X this out. That's not what we want to do. Do not distribute the square. What you do need to recognize is that this means 3 minus 6I times 3 minus 6I. And I think from here it's a little bit easier to recognize that that's not going to be enough of the final answer. We need to actually multiply this whole thing times this whole thing. So you got two options. You can either FOIL, which means you multiply your first terms. So you will get the 9. 3 times 3 is 9. And then you multiply your outer terms, 3 times a -6I, -6I times 3. And that's what you're missing here. You're missing all those middle pieces that you get from the first and the last, and then the outer terms, the inner terms. I actually prefer to use an area model. So that's kind of what I'll set up here. At the end, I'll show you that they both do work. But this is a binomial times a binomial, so it's a 2 by 2. So I like to set up a 2 by 2 grid. And that gives me a clear space for every piece in here times every piece in here. So it'll be 3 minus 6I, and then we've got 3 minus 6I. 3 times 3 is 9. That's where the 9 comes from. 3 times a -6I is -18I. 3 times -6 is, again, -18I. And then -6 times -6, that will also give us a positive 36. Which, by the way, when people distribute the square, often they forget that it's got to be anything times itself. So -6 times -6 is 36, and then I times I is I squared. And this is really important. This was where we need to recognize that when we have I squared, we're actually going to replace it with -1. But before I do that, let me take all my terms from inside my area model, right? All of these terms need to be added up, and especially the like terms, the I terms, need to get put together. So I'm going to end up with this: 9 minus 18I minus 18I plus 36I squared. So let me get my like terms together. That's this. This is going to be 9 minus 18 and 18. I believe -36, but you can always do this. -18 minus 18, -36. Okay. And now we have plus 36 times I squared. So this is really plus 36, but it's times a -1. So this actually is not an I term. This becomes one of the real components. It's a real number. It's going to get combined with 9. 9 minus 36I minus 36. Now these two need to get put together, right? They are like terms. So this and that, and the minus goes with it. And you just got to do 9 minus 36, which I believe is -27. Yeah. And so that should be our final answer. It's the real component and it is the imaginary component put together to make a complex number. A complex number is when you have a real component and an imaginary component. That is standard form, and they did ask for the answer in standard form. So that's what they're looking for here. You can see all the problem kind of at once. Multiply it all out, and here's where you end up. Message me anytime with questions.